Okay, we are going to be talking about slopes of lines. So we've already talked about some parallel lines and transversals and what that means for the angles. And so now we're going to look at the slopes of different lines. So slope in general, there's some very important parts. We're going to have 2 points, x1, y1, x2, y2. That's how we label them, just like we do for midpoint and distance. And what slope is it's that n, and it's equal to y2 minus y1 over x2 minus x1. And remember, when you're plugging in points for your x1, y1, x2, y2, it doesn't matter which one's your ones and which one's your twos, but x always has to come first. What slope is it's how steep something is. So it's how steep maybe a ladder is. This is your ladder against, the roof of your house. It's how steep something is. It's also called, you'll hear it called sometimes the grade. So if you're like driving down the road, you might see a grade is 7%, and that means how steep the mountain you're going down is. It can also be called a rate of change, which specifically describes how a quantity changes over time. So in relation to time. And so all of these things are just describing how this line changes, how it gets more steep or goes down. And you're familiar with the concept of rise over run for slope. It is m, and the formula we've already discussed. But sometimes we'll call it change in y over change in x, and that's what this triangle means. It's actually a Greek delta, and it means change in. So you might see this sometimes in chemistry or physics for change in temperature. This means change in y over change in x. And here's our formula. And it is rise over run. So the first thing you're going to do is you're going to put 2 points if you're on a graph, and you're going to count the rise, and then you're going to put it over the run. Or you could start here and count the rise and put it over the run, and those would be negatives. So we have up and to the right are both positive, and down and to the left are negative. And here you can see our different types of slopes on our little slope tree. So positive is going up, negative is going down. That makes sense. These are the two that normally get confused. Horizontal is 0. The slope is 0. Vertical line has an undefined slope. Very important. Don't say no slope, because does that mean no as in 0 or no solution like undefined? So don't use that. Be very specific. Horizontal has a slope of 0, and vertical has an undefined slope. Okay, so let's try this. Find the slope of the line using the slope formula. And so just by looking, it's going down, and I can tell the slope will be negative. So I'm going to plug into my formula, but first we need to know our coordinates. So negative 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So I have negative 3, 7, and negative 1, negative 1. So I'm going to plug in, and again, it doesn't matter what's your x1, y1, and x2, y2, you could swap it and you get the same answer. But if I do this, I'm going to do y2 minus y1 over x2 minus x1, which is minus a negative 2. So I get negative 8 over, over 2, which is a negative 4, and that makes sense because we knew it was going to be negative. You can, of course, also count. So we can say, okay, well, we rose 1, 2, 3, 4, 5, 6, 7, 8, and went over 2. So that's 8, and that's 2. And so, but remember, it's negative because I went left at negative 2. So my rise over run is 8 over negative 2. Okay, well, if I pick 2 points here, I have 0, 4, and 0, 1, 2, negative. Okay, and so by looking at it, we know it looks like our vertical line, which is undefined. Let's see why, though. So I'll do negative 3 minus 4 over 0 minus 0, and I get negative 7 over 0. Is it okay to divide by 0? No, it doesn't work. So the slope is undefined. And if you can't remember whether you can divide by 0 or not, sometimes it gets confusing. I've seen this trick that I like, and it is okay to have 0 on top, but it is not okay to have 0 on bottom. That's no. So 0 on top equals 0. 0 on top, no, it doesn't work. This is undefined. Okay, so 0 on the bottom is an undefined slope. And if you go back to remembering change in y over change in x, well, there's no change in the x value here. It's staying the same. And so there's no change. It's not going left or right. It's only going back up and down. So there's no change in x. There's a 0 on bottom. So a vertical line is always going to have an undefined slope. By looking at this, we know the slope will be positive. And we're going to pick our points. I got 6, 2, and negative 2, negative 5. So I didn't label my points here as x1, y1, x2, y2, but you know, that's totally fine, and you could have done it backwards. So I have negative 7, negative 8, which reduces to 7 over 8 as my slope, and let's check it with a graph and see if that's what we get. I'm going to start at this point. 1, 2, 3, 4, 5, 6, 7. Where I know to stop is when I'm in line with the other. So that was 7, 1, 2, 3, 4, 5, 6, 7, 8. Yep, my rise was 7 and my run was 8. Okay, so this is a horizontal line, so it should be a slope of 0. So let's see. So negative 2, negative 1, and 6. So if I do negative 1 minus a negative 1 over 6 minus a negative 2, I get 0 over 8, 0 on top. So because there's no, in this case, there's no change in y, I have a 0 on top. So a horizontal line is always going to have a slope of 0. And again, how I remember that is horizontal has an O in it. Okay, I'd like for you to pause, work these 4. They gave you the coordinates, and then check yourself. Okay, so it's important that you are able to do this both by using, if I give you coordinates or if I give you the picture. Okay, so I need you to be able to use both the formula and count rise over run. Here's a summary, and it's very important you know what those 4 look like, as well as having that formula memorized. Okay, so in 2000, the annual sales for one manufacturing of camping equipment was 48.9 million. In 2005, the annual sales were 85.9 million. If sales increase at the same rate, that's important because then that means it's linear, so it's a line. The slope is the same. So what will be the total sales in 2015? So there's 2 parts to this. Part is that we're going to use the data it gave us, the 2000 and the 2005 data, and then the second part is that we're going to predict what we think sales will be in as long as it continues. So this says use the data given to graph the line that models the annual sales y. So the sales are y as a function of the years x since 2000. Well, this is 0 years since 2000. This is 5 years since 2000. When we write that as a coordinate, our x is 0 because it says time is 0. And then for 2000, it was 48.9 million. Okay, so we got to remember that. And we can even maybe make a note to ourselves this is millions of dollars. And then for 2005, that's 5 years later, and it was 85. Okay, so now we're going to graph. And so we need to label our axis, find a scale. So down here, we are going to have years. And then specifically since 2000. So we'll start with 0. And then this will be, we'll just count by 2s. Because we have to go up to 15. And my y-axis will be dollars and in millions. So actually, it's the cells, right? So annual cells. Sorry, I'm going to read that. Annual cells in millions of dollars. And so we're going to put a scale on this, and I want you to kind of look at what we have. We know it's 48.9, and we know it then goes to 85.9, and then we know it has to go all the way up to whatever it's going to be in 10 more years after this. Okay, so I have the advantage of knowing what this is going to look like. So if you were sketching in this graph, you would just leave some room so that you'd have room to adjust if needed. I'm going to count each bar by 15, so 0, 15, 30, etc. Now I want us to plot our points. So 0, 48.9, this would be at 45. So somewhere right in there. And then 5, 85.9. So almost 90. And we know this continues in the same fashion at the same rate. So we could connect this, and ideally we would use a straight edge. And then we're going to predict. Remember, the next part was to find out what it is in 2015. So it looks like it's somewhere, now my line's not very straight, but somewhere maybe this would be 165. So maybe around 165, 170, somewhere like that. If my line was straighter, that would be a better prediction. But that gives us a good estimation of it's going to be somewhere in the 150 to 180 range. Like I said, if you use a straight edge, which I just can't do on my laptop, that would be awesome. So find the slope of the line. Use this rate of change to find the amount of cells. So we're going to find our slope. We could count on the graph, but that's going to be a little bit difficult since those were kind of approximations. So let's use our 2 points up here. We had 85.9 minus 48.9 and 5 minus 0. I want you to calculate that slope. So our slope is 37 over 5. And so the rise is 37, and in this case, $37 million. And the run is over every 5 years. So that would be our rate of change. Well, we can write that. It would be $37 million. And then per, right, every 5 years. So is that money over time. And you always want to give slope as a fraction. So that tells us our rise and run, with one exception. When we are doing word problems, sometimes it makes more sense to give it in a decimal. So in this case, this would be 7.4 approximately. And so this would be 7.4 would tell you that this is every year. So now it's 7.4 over 1. So the annual cells changes 7.4 million each year. So, and actually it's a positive slope. So it increases by 7.4 million each year. So that's two different ways of saying the same thing. Now we want to use the slope formula. We just used the slope formula to calculate the line. And we figured out that it increased an average of 7.4 million per year. In the next video, we will continue by predicting the 2015 slope and finish up the notes.